Good morning, everybody. Good morning, Jada. Good morning, Tidy. Welcome to Wednesday. We're getting there. We're getting there. Hello, JR. Or hello. It's a very cheery hello for a Wednesday morning that's gloomy outside. Morning brain fog. Wow. It's been a while since I've seen brain fog. How's it going? Matt, Joey, Tidy. Midterm day making me a little stressed. Yeah, understandable. I mean, I can say don't worry about it, but I have a different perspective from you guys. Be conscious, be aware, be a little stressed. But I don't know. The midterm is doable. It's doable, which is good. Flora, Matt, so homework 7, I'm gonna re-go over some things on homework 7. I keep seeing a lot of the same questions and issues over and over and over again. So I'm gonna go over some information about homework 7 that you guys might find useful before I get into midterm practice. On the test, how do we know if you want us to print to a certain decimal? So if you are not told, then it doesn't matter. If you are told, then you will be told if we care to a certain decimal. Sometimes on the test you won't be told whether or not to use display or fprintf. If it doesn't matter, then use whichever one you want. If you use display, you don't really have control over how it's displayed. If you use fprintf, pick something that might make sense for you. So if you're told to do it to a certain decimal, then you would do it to a certain decimal. If not, then it doesn't matter. Do we count the number of x on the example given to us, or will you explicitly tell us? I'm confused on that question, Flora. Do we count the number of x on the example given to us, or will you explicit? You can use it as a model. I know what you mean. Typically we say in the following format, xx point xx. You can use that as a format, but once again, if you are not told explicitly, then it doesn't, then you can choose what you want. Yeah, I can definitely go over that, Jada. Like I said, there's some common questions that I've seen, so I'm gonna address those today. We're almost there. Homework 7 is by far always the hardest homework. Other than the project, but the project is different. Don't worry, Matt, you will have more project stuff. But yeah, homework 7 is always the hardest. I've had students complain that homework seems really good, and then you get to homework 7 and it's like an extreme curve to it being so much harder. And that makes sense. Loops are different. The exam submission will be just like your homework. You will so I will talk about the exam in a minute. I want to go over the homework first just to keep everything nicely categorized in my brain so I don't feel like I'm going all over the place. Matt, I don't know. I think so, maybe. I don't know. Ask your advisor. Okay, so technically class is starting. There's already a lot of discussion. Let me go ahead and go over stuff for homework 7. So this question seems to be relatively straightforward for the most part. except for certain conditions. So this one, I haven't seen many questions on the upper, so I'm going to focus on the lower. So in MATLAB Grader, I created 3 specific tests on Monday that illustrate the different ways that our matrix might look like. So if we say lower 3, 3, then it's a square matrix. It should look like this: 1, 0, 0, 2, 2, 0, and then 3, 3, 3. And that one seems to be pretty straightforward for people. And it's also pretty straightforward if we have more, I'll do 3, 5, more columns than rows. Or more rows than, more columns than rows. So this one would look like 0, 0, 1, 0, 0, 2, 2, 0. Oops, missing some. There you go. It would look like that, where you have your triangle, and then anything out here is just more zeros. The issue seems to be when we have more rows than columns. So note, this wants to be a 5 by 3. So it should look like this. Note, I have 5 rows, 3 columns. A lot of times your guys' homework is looking like this, where MATLAB adds these 2 extra columns. And the reason is, when you fill in these rows, MATLAB doesn't tell you that you're trying to place 4 numbers when you should only have 3, or you're trying to place 5 numbers when it should have 3. This is one of those instances where MATLAB doesn't quite give you an error when it probably should. It just adds in that extra, it just adds in the extra space that it needs. So you need to make sure you have some sort of if statement that checks to make sure you're not going past the number of columns. So it works for 1, 2, 3, but when you get to 4 and 5, you need to make sure you're checking to see if the row number is greater than the columns and account for that. Because your program will run. It will run. But keep in mind, we want it to be a 5 by 3. We don't want it to be a 5 by 5. So that's the common error for problem 1. Common error for problem 2. So problem 2 is good. A lot of you guys seem to get the right structure, which is awesome. But then you have the issue of your number of iterations. So I saw someone posted on Discord mentioning that the number of iterations seems off in the MATLAB Grader. So I want you guys to keep in mind that when you're writing while loops, I want you to figure out when you want things to stop. When do you want your loop to stop? Put a question mark there. What does that conditional look like? So I want to stop when the error is greater than a tolerance. Or when the number of iterations is greater than 50. I think I'm the old one. And then you're going to invert it. So you're going to invert it. I can spell right. So that means you're going to just make it the opposite. So this would, the opposite of this would be E less than or equal, or to tolerance. Hold on. I want to stop when my error is less than the tolerance. I think I grabbed the wrong version. Sorry. So I want to stop when my error is less than the tolerance, which means when I invert it, that's going to be my continuation. So this is where your brain thinks, okay, I can keep in mind when I want things to stop. And this one's harder to come up with. So that's why we're going to start here and then invert it, make it the opposite, in order to figure out when we want to continue. Same thing with the number of iterations. I want to stop when n is greater than 50. So I want to continue when n is less than or equal to 50. However, keep in mind that this conditional here is going to depend on your initial condition. So So n needs to start at some initial value. And then inside your loop, you're going to have n plus 1. So if I go back over to this document, somewhere up here, I'm going to say n equals something. And then I have my loop, so I have while, etc. n greater than or equal to 50. And then somewhere in here, I'm going to increment the number of iterations. N equals n plus 1. This happens at the end of your loop. This increment is at the end of your loop. So depending on what you start this n value at, by the time you get to the end of your loop, it's going to be incremented by 1. Ooh, drop my pen. So if you start n at 1, if n equals 1, when you get to the end of your loop, n is going to equal 2, even though you've only done one iteration. So there's a connection between what you want your initial value to be and when you increment your n. So make sure that when you exit your loop out here, when you're done with your loop, that n contains the exact number of iterations. Exact number. If that means you print out something in here every single time to make sure you're counting the exact number of iterations, do that. Another thing with this problem, a lot of you guys, you're running into issues. Print everything out. Print everything out. This is so essential when it comes to debugging loops and figuring out what's wrong. Some of you guys have run into infinite loops. An infinite loop never stops. If you run it in MATLAB, it won't stop. It legitimately will not stop. It will keep going forever and ever. You press Control-C to stop it. If you run it in MATLAB Grader, it will time out. It'll give you this error. I can't remember what it says, but it'll give you this error. It says something like program timed out. That means that you have an infinite loop. It kept running and running and running, and it didn't stop in the time limit that MATLAB Grader gives you. So print everything out. In here somewhere, say print f. Print out your number of iterations. Print out what your error is. Percent %f. And print out lots of digits past the decimal place. If your tolerance is 10 to the negative 6, you're not gonna catch it if you only print out 4 digits past the decimal point. So print out like 10 digits past the decimal point. Print out VMP new. Print out VMP old. Whatever you call your variables. Print everything out, because then you'll see what's happening. You'll see, oh, is my n value changing? Am I counting the actual number of iterations that I'm supposed to be counting? Is my error changing? Is my VMP new changing? Is VMP old changing? How would the application of break work here? In theory, you could also redesign this loop to say, while your error is greater than tolerance, and then do everything. And then in here have a break statement that says if n is greater than 50, break. If you can read that, that's what that says. So you could also use break technically. Once again, I don't encourage the use of break, or continue really. But you could do this. You could have an if statement inside of there that says if n is greater than 50 or whatever it needs to be in order for you to have exactly 50 iterations, you could say break. So that's another way that you technically could design this loop. Okay, that is problem 2. Hopefully that helps clarify some things. This is key. Printing things out. This is key. A lot of you guys are just sending me code and you're like, I don't know what's wrong with it. Which is fine. I can look at your code. I've sent a couple people back that says print everything out. You need to see how your values are changing. It's a very good strategy in general, something you need to learn. Okay, for the last problem. Integral. So the integral function, the goal is to calculate this equation here. Oh, Matt, you weren't the only one. There were several other people. So we know how to do I equals h over 3 times a plus b plus c plus d. We know how to do that. So this here, a would be y of 1, 4b and 2. I'll put these constants in there. B and c, these are sums. Sum 1, sum 2, whatever you want to call it. Some even, some odd. And then d, y, end. These sums are calculated with our for loops. So whenever you see this sigma, that means for loop or while loop. It means loop. I equals 2, 4, 6, all the way to m. And these numbers here, these indicate what goes next to your for. So for I equals, call it I. Call it whatever you want. And then what are your values of I? What's your starting number? What's your increment? What's your ending number? That's how you translate a sigma into a loop. Anytime we sum numbers, we say sum equals 0 before our loop. And then we have sum equals sum plus our new term. You need to decide what your new term is. What are you adding together? And once again, that does come from your sigma as well. Look at your sigma. This means add a bunch of things together. What are you adding together? It's usually right here. Okay. So you have two sigmas. That means you should have two loops. Okay, so m, where x is a vector of m plus 1 evenly spaced values. So x is a vector of m plus 1 values. So that means x has m plus 1 values. So look at an example. If x contains 1 to 10, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 10 values. M is going to be 9. X has m plus 1 values, therefore m is 9. If x is 1 to 10, then I've got 1, 3, 5, 7, 9. Then m here is going to be 4. Because x has m plus 1 values. So m plus 1 values. So note here, m is equal to the second to last value. That's just coincidence. So you can't just take the the x end minus 1 value. You have to figure out a different way how to find how many values x has, and then you can get m. Okay, so that's the integral function. For this part down here, you are just going to use your function to calculate the integral. So you're replacing this part right here by calling your function. Integral, that's how we call a function. We write the name of the function, open close parentheses, and then we send it some data. X, Y, whatever data needs to be sent. X should contain your independent variable. It's whatever x would be in your function. In this instance, it's going to be t. And then y contains your y, your function, which is this calculation here. So x here, these are your limits. That's where they come into play with creating t. And then what are you integrating? What are you summing up together? Yeah, Tidy, you're right. Here's your, ooh, that's a terrible line. Here's y. So you just call your function. You don't need to copy paste your code. You have your function. I equals integral 1 to 10 dot squared. Like you can call your function with anything that you want. This would calculate the integral of 1 to 10x squared. So now your function here does this integral. Where these are your limits identified by your x vector, and then here's your function and y. But you just call your function. If you copied and pasted code, then that would defeat the purpose of writing the function. So that's how we're going to use our function. Literally just like any other function, just like you use the size function, just like you use the cosine, log, sum, size, length, all of that fun stuff. Okay. Hopefully that helps. It took a little bit longer than I wanted to, but your homework is due tonight. It's essential that you guys understand these concepts. It's all review for the exam anyway, because we're just practicing and practicing and practicing. And this homework tends to be challenging. Okay, so hopefully that helps. Let me go ahead and transition into talking about midterm practice. So your midterm is Saturday, as you guys know. The Zoom link is coming, but you guys are going to go onto Zoom. The exam is going to be released on UB Learns. So if you go to UB Learns, you'll see in week by week material, you'll see that midterm folder. Right now, you'll see the practice problems, which I'll go through as many as I can. Today with however much time we have left. You'll see solutions as well. So anything I don't get through today, I will create video solutions as well, so you guys can see me talk through the process and what to think and different ways to solve things. I'll post those. But your exam is going to be released in that folder as well. So on Saturday, sit down at your computer a little bit early. Make sure you log into UB Learns. Make sure you log into UB Box. Make sure you log into UB Zoom. Yeah, so you need to log into all three of those things. UB Learns, UB Box, and UB Zoom. Then you'll be nice and prepared. I'm so sorry, Tidy. So you'll be prepared. Okay. When the exam is released, it'll be released at noon. You'll click through, you'll say begin. You will have 90 minutes to have access to the exam, and then 10 minutes to finalize everything and submit. You'll click begin, and you'll be presented with 6 different problems. Those problems are just going to be links to box files, to UB box files. So you'll have 6 links, then you'll click on each of those links. I encourage you guys to click on all of them right away. It'll open up UB box, and you'll see the problems you have to do. Okay, so just like you do for your homework. And so make sure, once again, before you begin your exam, you're logged into UB box. Then you won't have to deal with logging things in right away. Okay. Start with one problem at a time. They're arranged. I mean, you'll have access to all of them, so you can choose which one you want to start with first. They're kind of arranged in a difficulty order, maybe not, but just open them all at once and click through, see which one you want to start with. Oh, another thing to do before you gain access to your exam. I want you guys to open up MATLAB. You'll open up MATLAB. So JC, that's a really good question. So your exam is going to be proctored on Zoom. What you need to do is your phone is probably going to be used for your camera to be placed somewhere so that we can see you working on your exam and with your computer. I forgot to mention that. So everybody's going to be in the same Zoom room, but then you're going to be placed into a breakout room. So log into Zoom, probably on your phone. Log in. You'll need to be logged in with your UB account in order to be admitted into the Zoom room. And then you'll plug your phone in so it doesn't die. And then you'll place your phone somewhere over to the side so it's propped up somewhere so that the camera is watching you. Unless you have two other... If you have a webcam that you want to place somewhere else, that's completely fine as well. It just needs to essentially view you more or less from the side / angled at your computer. I don't know why taking pictures of the problems would make that big of a difference because they're still all going to be in 3 different documents. So I encourage you to work on one problem at a time. If you have, gosh, I don't know how people live without more than one screen. I'd say if you have a desktop with more than one screen, that might be useful. But I don't know. But anyway, that's what you're going to have to do. Unless you have 2 other devices besides PC, you can't use one. Split screen. Yeah, I mean, you guys can deal with your screen however you want. It is your control on how you want to deal with things. Like I said, you have access to MATLAB, you have access to UB Learns, your textbook, your notes, however you want to gain access to that material. I encourage you guys to create a couple cheat sheets that tell you how to do specific things. So how do you write a switch statement? If you really struggle with knowing what a switch statement looks like, write down, okay, what's my syntax for a switch statement? So that you don't have to go sorting through anything on your computer. You can just look down and you're like, okay, that's what it looks like. You can print out notes. You can really have anything that you want with you. You just can't be talking to other people. You can't post your problem for someone else to solve it. Like, you just need to solve your problems. The Zoom link, I will email it out to you. I will post it on UB Learns as well. I just haven't created it yet because I don't have all of the information because you guys are going to be assigned to breakout rooms and I can't assign breakout rooms unless I have all of the information. So yeah, I'm going to email it to you and I'm going to post it on UB Learns. Okay. So before your exam, I'll write all this down. Before your exam, log on to UB Box, log into UB Learns, log into UB Zoom on your phone, open a MATLAB. You can use, when you say sources, you can use your notes, you can use, it's open book, open notes. You can Google things if you want. You just can't have other people solve your problems. Okay, so, when you, there we go. So also, no, I'll share screen. There we go. So also, open MATLAB, create a folder. So in your current folder, just say new folder, right click, new folder, say midterm, so that everything is nicely saved in there. And then you can have all of your problems in the same folder. You can save them. So at the end of the day, at the end of the hour and a half, 90 minutes, however long it takes you to finish in those 90 minutes, you'll have your 6 files here. Yes, anything and everything except people. Once again, you only have 90 minutes, so don't be shuffling. Try and keep things as, use those other resources as like more of a last resort. Like, I cannot figure out what's happening. Also, remember, you get partial credit. You're not graded on whether or not your code runs perfectly. Like, it's not all or none. Yeah, you can just right click, create new folder. You can copy paste things in here. So no, not in MATLAB Online. If you're using MATLAB Online, make sure you open it, gain access to it. Same thing, you can do this in MATLAB Online too. You can right click or new folder. It looks a little different in MATLAB Online. Let me show you MATLAB Online as well. So once it opens, it automatically opens to your MATLAB drive. Here's your current folder. You can see I already have a bunch of folders in here. You can just go to new folder, and then you can name that one midterm. But somewhere where you can see that, okay, I'm dealing with just these files. Come on, double click. Open. There we go. So somewhere where you just have these files. If you are in MATLAB Grader, or MATLAB Online, just keep in mind you can't download all of your files at once. You need to download them separately, which is totally fine. Just make sure you're accounting for that in terms of time for that 10 minutes of submission. Okay. But open up MATLAB and just create that new folder. Okay, then you're going to open up your problems. For example, you might have a problem that looks like this. Write a function b equals modify array a comma n that takes a square array of arbitrary size m by n and n as an integer equal to the required size of the new array. There's going to be a lot of jumbled text in there. Read it as carefully as you can. Do not spend too much time trying to comprehend everything. But just know, here you have a function, modify array an. A is a square array of any size. N is an integer equal to the required size of the new array b. Okay, so you know you need to write a function. Go over here, function b equals modify array a comma n. I would encourage you to not worry about writing too big of variable names. So technically you don't even need these variable names if you don't want them. Like for this problem 2, it says checker. You don't need to call it checker. You can call it C. It doesn't matter. It's just an output. So try not to do large variable names just because that takes time. Okay, so you started there. Go ahead and save it. I'll do the split screen. There's not much size here though. I'll zoom out. So you can go ahead and save it. So now modify array. Now you have your first file, and then you can just keep editing it. If n is less than m, the function must reduce the size of a from m to n. Okay, so you've got a bunch of variables in here. You have a bunch of letters in here that you need to figure out what they mean in your program. It might be easier if you named things in your program the same as they are written down. So I've got this if statement here. So if n is less than m. So in your program, you know you need an if statement. You know you're going to be dealing with n and m. So n is already in your program. N is this number right here. M is the size of a. So create a variable called m as the size of a. Size of a, comma 1. You could use, so a is a square matrix, so it doesn't matter whether or not you take the length or take the number of rows or the number of columns. Remember, this would tell me the number of rows specifically. This would be the number of columns. If you wanted both rows and columns, use size of a, comma 1. Or size of a, my bad. This one. Comments do not matter. If you have a second device, sure, if you want to. Use comments if you want to, but they're not required. JC, what would you use a second device for? Would like to contain all of your notes and everything? Like a iPad or a tablet or something? Okay, so I have m. So now I have n and I have m. I need my if statement. If n is less than m. I haven't even read the entire problem yet. I just am building it up from the top down. So if n is less than m, the function must reduce the size of a from m by m to n by deleting rows and columns of off the bottom and the right. There's a typo there. So there is an example here. This example doesn't match that one, but you can write your own examples. Okay, so thinking in your mind, if a looks like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, then here m would be 3. Let's say n is 2. I need to delete off the bottom and the right. So I just need to keep this square matrix here. So JC, that is fine. Just make sure that you're not trying to access the test on both devices. Because I don't want to run into an issue where you shouldn't be able to open up 2 tests, but I don't want to run into an issue where you are solving the wrong problems or you get a different set of problems. So just make sure if you're accessing your test, only do it on one device. So if n is less than m, I just need to chop off parts of a. So there's a couple ways you can do it. You could delete off of a as well. So delete all the rows off the bottom, n plus 1 to end equals delete. N plus 1 to end, comma, equals delete. That's one way to do it, where you could literally just delete the columns off of A. Another way to do it is you could just say that B equals A 1 to N, comma, 1 to N. Okay, so there's multiple ways to do these problems. One might be easier than the other. These two literally delete these rows and columns. This last one literally just grabs the numbers that you need. Do whichever one makes sense. There's more than one way. If it works, it works. If it doesn't, try something else. Okay, so that's the first one. So if n is less than m, and then I have a second condition, if n is greater than m. So I could say if n is greater than m. Technically, this is valid. Technically, I could have two separate if statements. These two are related. You have one of two scenarios, if n is less than m and if n is greater than m. So you should have one complete combined if statement. So if n is less than m and else if n is greater than m. You could have an else in here. The problem statement does say if n is equal to m, then no change is required. You also do not need it. So I've got two options. It's either n is less than m or n is greater than m. No, there's no greater, so you're not going to know whether or not your code is correct, which is why you're not graded solely on your output. Like the grader will go in and grade you essentially line by line. Okay, so if n is greater than m, then my function is going to add 0 rows to A, rows and columns, to increase its size to n by n. So that's where this example comes in, where I need to add zeros here and add zeros here. So once again, there are different ways to do this. You could add the zeros to A itself. You could say A colon all rows n plus 1 to n equals 0. A n plus 1 to n all rows. Oh, no. Nope, that's not how you would do it. You would say, how would you do it? M plus 1 to n equals 0. I've written these problems for the last several days, specifically these kinds of problems. So these are fresh in my mind on how to do things. You might not have caught that right away, and that's completely fine. Write it, test it. So another way you could do it is you could say b equals zeros of size n by n, and then b 1 to m comma 1 to m equals a. Okay. So there's two ways to do this one as well, or there's more than that. One thing you need to do is test your function. Test everything. We have 3 scenarios. We have A and n, where n is less than the size of A, n is equal to the size of A, and n is greater than the size of A. Go into your command window. Technically, you could also type it up here. Well, not if you name the file the same. Go into your command window and create an A. A equals rand I 10, 3, 4. You guys have seen me do this. You've seen me use rand I many times. I encourage you guys to use it to create an arbitrary size A. Then you don't need to come up with numbers yourself. You can just say, let's say A looks like that. Come on. And it's not going to make a difference. then you would type your function. So b equals modify array. Let's say n was 2 in this instance. Okay, so good. It chopped off these last 2 columns. It chopped off this last row. Perfect. Let's say, oops, A is supposed to be square. My bad. A is supposed to be square. 3, 3. Okay, so it worked if n was 2. Let's see if n was 3. Okay, so now there's an error that is called. Note, there was no error when n was 2, but there's an error when n was 3. So it says output argument b may not be assigned during a call to modify array. So I could have an else here that just says b equals a. So if n is equal to m, b equals a. I could do that. Whoops. Don't run your functions. So I did something, I tested it, and now it works. Okay, so now what if a is 4? Okay, so here we go. It added those 0 rows. So Zanzib, would a rubric of how it's graded or just the correct values be given for the questions? There is no rubric given for the questions. There is a number of points for each question given. So if you look at your test, you should be able to see the number of points. When you take your quizzes, can you see the number of points that each question is for? It's going to look the same. It'll tell you how many points that question is worth. So some questions are worth 8 points, some questions are worth 10 points, some questions are worth 12 points. The total exam is 60 points. Okay, but make sure you test your function. If you have an if statement, check each branch. Check what happens if this is the case. What happens if this is the case? What happens if this is the case? Let's say you did it this way. Where instead of using B right away, you just deleted things off of A. Test your function. So what if, okay, so if n was 2, it says output argument B is not assigned. You need to make sure that B equals A in this instance. That means you didn't assign your output. So you didn't say B equals anything. Okay, so you make a change, test it again. That one worked. What if A was 4? Okay, it added those zeros. If you're testing your function and you want to do a little bit more debugging, assign your outputs. So what would an example A be? What would an example N be? So N equals 4. Highlight your code. Okay, what happens if I do this? What happens to my A if I do that? What happens to my A if I do this? You can't just run your function, you have to test it, but that means you can't see what's happening line by line. So highlight, right click, evaluate selection. That will help you debug your functions. Okay, that's our first question. Okay, so we've got that one done. Just click new script file and keep going. So the second question. Write a function checker equals checkerboard mn, which creates a checkerboard pattern of 1s and 0s with m rows and n columns. The 1, 1 position should be +1, and the remaining rows and columns should alternate between +1 and 0. There's an example. Use this as an example. You are essentially creating this matrix. Okay, so once again, you're writing a function. Start there. Function. It says the output is checker. That's too long. I'm gonna say C equals checkerboard m, n. It doesn't matter what you name your input and output variables because they're separate from your script file anyway, or from your command window anyway. So name them whatever you want. Just make sure you use the right names. I encourage you to use the ones that were given because that is how they are just explained in the document. So it's easier to keep track of your thoughts and what's happening when you do name things the same, but you do not have to. Okay, so I need to create that checkerboard pattern. So I'm gonna start out by just saying C equals 0s of m, n. That's how big it's supposed to be. C equals 0s of m, n. Now I want to iterate through an array. There are two ways that you can iterate through a two-dimensional array. If you are iterating through a vector, you would say for I equals 1 to the length of your vector. And then you can do something. If you are iterating through an array, a two-dimensional array, then there's a couple ways you could do it. You could say for I equals 1 to null, so the number of elements, and use a single loop. This is the first way, so iterate through all the elements. And this will iterate through them column-wise, so it'll take the first number, second number, third number in the column, then go to the next column, then go to the next column, and that's fine. Or you can do two arrays, or two loops. So you can say for I equals 1 to the number of rows, and then for j equals 1 to the number of columns. In this example, m is the number of rows and n is the number of columns. You might want to use the size function, so r comma c equals size of c. And do r and c. Either of these are valid. That was a lot. So this, you could just iterate through all of the elements. Here is iterating through the rows and the columns. Explicitly. This one does too, it's just this one's more explicit. So now you're trying to create this checkerboard pattern, alternate. So you might think that I could do this one and just say C of I equals 1. And you can write an if statement that says if I is odd. So if I want to figure out if a number is odd, I say mod I comma 2 equals 1. This is check if it's an odd number. So this is one way we could potentially do it. And it should more or less create our checkerboard pattern. Maybe it will, maybe it won't. Try something, see what happens. So I'm gonna call my function c equals checkerboard. Let's do a square matrix. Let's do a 3x3. Checkerboard, spelled correctly. Save your function. There we go. Make sure you save your function. Okay, it created my checkerboard image. Perfect. Or my checkerboard pattern. Okay, I did that with a 3x3. Try it with something else. You could try it with a 3x4. Okay, it still worked. What if I had a 4x4? A 4x4 doesn't work. Okay, so now I need to figure out, okay, it's not working for all instances. So what do I need to adjust for? Could you also do an if statement where 1 is placed through linear indexing? Sure, yeah. Another way you could do, there's lots of ways to do this one. So let me show you how to do it this way. So we could do with rows and columns, where I'm gonna place the ones in each row individually. So I could do it like this. Let me do it this way. So let's say we're gonna iterate through all the rows. I'm gonna place the ones in the rows individually. So if it is an odd row, then I am going to place the numbers, I think this is what you mean, Zanzib. If it's not, let me know. I'm gonna place it in all the odd locations. So I'm gonna say C1, comma 2, comma end equals 1. So this will do all my odd rows. And my even rows, then I'm gonna say C2, comma 2, comma end equals 1. Ooh, this is fun. I didn't think about this way before. So here's my even rows. Place in odd locations. Place in even locations. Okay, so let me comment this one out. No. Comment. Okay, so let's see if this works. Like I said, this is exciting. Okay, so once again, go back to a 3x3. Okay, so it doesn't work for a 3x3. I did something wrong. So if mod I comma 2 equals 1, yep, that's an odd. 1 comma 2 comma end. I did not identify, this is a matrix, so I need to say for a given row. So I comma. Okay, so now let's do this again. Nope, okay, yeah, so this one worked. Okay, so it placed all of them. Let me check for a 3x4. That one worked. Let me check for a 4x4. That one worked as well. Yay, I changed it. I modified it. So here is how it's working. Another way we could do this problem is we could use our nested loops. So for I equals 1 to R, go through all the rows. For J equals 1 to columns, number of columns. And I notice I want to place it in the 1, 1 location, 1, 3 location, 2, 2 location, 2, 4 location. So I notice that if I add those two rows and columns together, so if I plus J is equal to an even number, so I plus J here is 2, I plus J here is 4, 4, 6. So if I add my row and column number together, then I get an even number. So if you want to check if something's even, you say mod I plus J 2 equals to 0. So you just check for even number. Okay. Then you would say that Ci comma J equals 1. So here's another way we can do this. So once again, double check, see if it works. Nope, I commented out that line. There we go. So that also gives me my checkerboard image. So there's sometimes multiple ways to do things. If you can think about it in each row at a time this way, that'll be much easier than if you use nested loops. So like I mentioned previously, a lot of times you don't need to use nested loops in MATLAB. A lot of times you don't even need to use loops, but either one of these will give you credit. This one won't give you full credit because it doesn't work in all situations, but you will still get credit if you do it this way, if it's not perfect. But I encourage you guys, you need to make sure you check your code with lots of different options. Just like for the homework problem for lower and upper, checking for all those different options, does it match what you expect it to match, what you wanted it to match? Okay, well, we got through 2 problems. I will solve the rest of the problems. I will post the videos to those. I took a lot of time to go through the homework today, which is fine. But I will post the videos to the rest of the problems. I'm going to let you guys go 3 minutes early as opposed to 3 minutes late so I can head over to office hours. But the exam is doable. You guys got it. It's just practice and coming up with examples, I encourage you guys to have paper with you and a pencil or a pen that you can write down and jot down ideas, write down examples, identify what you want to do. Because these problems aren't necessarily just regurgitate. It's here's a problem. It's similar maybe to what you've seen before, similar to the problems in the set of practice problems, similar to some of the homeworks. But it's not do this calculation that you've done 30 times. It's can you take this problem and use the tools that you've been given in order to solve it. Okay. I will see you guys on Saturday. I will post things, email. You guys got this. Yes. So Aurora, you can look at old code. Yep. Like I said, you can access whatever you want. You can access the solutions, whatever you want. Just keep in mind, you're gonna have 90 minutes. So try and come up with a couple different cheat sheets that give you a lot of the information that you want, and then use those other resources as more of a last resort. Okay, let's, with that, I'll head over to office hours. I'll see you guys on Saturday.